Traditional plastic bags are primarily made from finite, non-renewable resources including coal, natural gas, and crude oil. They are often made of polyethyl, which is produced using either low-density polyethyl or high-density polyethyl. The additional polymerization reaction occurs in the presence of peroxide, making the double carbon bond in ethene has the potential to crack, leaving just one bond between the carbon atoms, and the capacity for each atom to establish another bond is shown in the figure below. Plastic bags are made mostly of hydrobombing polyethylene, which has a long carbon chain molecule structure that prevents them from decomposition under normal circumstances. This type of plastic bags are relatively degraded slowly on land or in the water, making disposal difficult and producing a variety of hazardous compounds. The introduction of also biodegradable plastic bags contain peroxide breaking down the polymer chain for biodegradation. Traditional metals such as cobalt, manganese, nickel, ions can act as a pro-oxidant to give the finished product a biodegradable properties.
Plastic is a type of synthetic organic polymers derived from petrochemicals such as polyethylene, polypropylene, and PVC. During the process of converting resin to plastic, additives like fillers, plasticizers, and colorants are added into resin to enhance strength, durability, and insulation. Although plastic has excellent properties, the disposal of plastic is problematic as plastic stays in the environment for centuries, causing long-term pollution. The aim of oxo-biodegradable plastic is to maintain benefits of traditional plastic with improved disposal. It is created by introducing pro-oxidant, initiating fragmentation when exposed to heat and light. There are two degradation stage processes which are abiotic and biotic processes. In the abiotic process, pro-oxidant induce oxidative degradation under heat and light. In biotic process, microorganisms convert oxidation products into carbon dioxide and biomass.
Recently, also biodegradable plastic packaging, including carrying bags, has been promoted as a solution to plastic pollution. It is designed by following two circular economy principles, which are reducing waste and pollution and maximizing material use. Although biodegradable polymers emit harmless emissions than regular plastics, it takes 1 to 3 years to biodegrade in an air-exposed environment. There are a few challenges and considerations of using also biodegradable plastics. Although biodegradable technology discourages landfill biodegradation, this plastic in landfills has been disposed of in an anaerobic condition. This situation will produce methane, which is a potent greenhouse gas. Besides, heat, light, moisture are the variables that affect biodegradation, thus mitigating real-world circumstances in a laboratory setting is challenging.
The oxo-biodegradable plastic was analyzed by using two methods, and one of the methods is FTIR spectroscopy to study the presence of functional group in the structure. So the strong band visible at the wave range of approximately 2913 and 2846 correspond to the stretching vibration of the CH metalline group. Then the presence of bands in the range of 1469 indicates the bending vibration of CH bonding. Lastly, the visible strong band at the range of 716 indicates the mono-substituted CH bond stretching. So the result shows that the oxo-biodegradable plastic contains high-density polyethylene (HDPE), which is a pure form of PE, that the polymer chains are absent of methyl side chains containing only the CH2 groups. So the polymer chains can be packed closer together, resulting in a denser material. The HDPE is selected in the plastic packaging manufacture because of its low cost, flexibility, waterproof, temperature resistance, and rigid compared to the LDPE (low density polyethylene) and LLDPE (linear low density polyethylene). HDPE is not biodegradable in nature, but the additives of pro-oxidants such as the methyl salts will enhance its oxo-biodegradability.
The also biodegradable plastic was analyzed by SEM. So the figure 1 shows that the SEM image of also biodegradable plastic under magnification 5,000 times, and figure 2 show that the SEM image under magnification 2,000 times. So the figure 3 show that the SEM image under magnification 5,000 times. The SEM image above or temp when performing SEM analysis on also biodegradable plastic to study the surface morphology. From the image obtained, the smooth and uniform film surface can be observed in each magnification. However, the spherical particles on the surface are the contaminant which due to the improper sample preparation.